Hey guys, my name's Ashley and I'm here to keep you in the know about some of the most interesting and talked about scientific topics. On last week's episode, we focused a bit more on coral bleaching. This week's episode is a follow-up on that and we're going to learn about ocean acidification. So let's get into it. Since the industrial era, there has been a huge increase in carbon dioxide concentration in our atmosphere. A really large portion of that carbon dioxide is actually absorbed by the world's oceans. Now, this is good because it helps regulate how much carbon dioxide is in our atmosphere, but it's not good because what's happening with the carbon dioxide when it gets to the ocean? The carbon dioxide is absorbed into the ocean and mixes with H2O, or seawater, to form carbonic acid. Carbonic acid is a weak acid, so it's broken down into hydrogen ions and bicarbonate ions. Having more hydrogen ions results in an overall increased concentration, which is what's making the ocean have a higher acidity, thus a lower pH. In order to better understand this, first you have to understand the pH scale. So the pH scale runs from 0 to 14. 7 is considered neutral, and that's the pH of our drinking water. As the number gets smaller than 7, that means it's becoming more acidic, and as the number becomes larger than 7, that means it's becoming more basic. An example of a really strong acid would be HCl, and that's the kind that you find in your stomach that breaks down all your food. An example of a really strong base would be something like bleach. The ocean typically sits at a more basic pH of 8.2. However, in recent years, scientists have calculated that it has now dropped to 8.1. Now, you might notice 0.1, that's not that big of a change. Well, think again. The pH scale is logarithmic, which means that a strong acid essentially has 100 million times as many hydrogen ions as a strong base. Even a change in 0.1 is equivalent to a 30% increase in acidity. By the end of the century, scientists estimate that the pH of the ocean is going to get to around 7.8. That is a huge change, and that is going to severely impact marine organisms. Now, let's rewind to last week's episode when we talked about what makes up a coral skeleton, and that's called calcium carbonate. Calcium carbonate is what makes up the coral backbone and what makes up a lot of shells in the ocean. The ocean is what is called supersaturated with both calcium and carbonate ions. They take the calcium and the carbonate ions from the ocean, form it together, and make calcium carbonate. The carbonate ions that normally are supersaturated in the ocean bond with these extra hydrogen ions in order to form more bicarbonate. When the ocean doesn't have as much carbonate ions, now these organisms can't calcify and make their backbones and shells. This causes the backbones and shells to not form, be weaker, or dissolve entirely. Corals and shelled organisms aren't the only animals being impacted by the increase in ocean acidity. This is seen in fish such as pollock and clownfish, which have a harder time detecting their predators. It's also seen in larval clownfish, which have a harder time finding a suitable habitat. This has the potential to mess up the entire food web because larger fish rely on these smaller organisms to eat, and humans rely on these larger fish as a source of food as well. That is why it's really important that we can tackle this issue sooner rather than later. So, on the contrary, algae and seagrasses thrive on this increase in carbon dioxide. Carbon dioxide is necessary for them to do photosynthesis to make oxygen and sugars. So, an increase in carbon dioxide is actually good for them. That's why, like on land how we're planting trees, we can increase the amount of seagrasses in the ocean so that more of this carbon dioxide can be absorbed. And now you know what ocean acidification is. Thank you so much for watching. Like and subscribe below to keep up to date with all my latest science videos. See you next time.